Wow, it's another beautiful day, and it's a moment for us to continue with our studies in chemistry. Now, if today happens to be your first time coming across my video, don't forget to subscribe and click on the notification bell for more video lessons. If you're a chemistry lover, then you are at the right place. All right, so in our previous video lesson, we ended on understanding the atomic number. Now, the previous video link is within the description. You can check it from there. All right. So today, let's proceed by moving on to applications and importance of the periodic table. Now, so the periodic table guides scientists in predicting and understanding the behavior of elements in chemical reactions. So, in our previous lesson, we learned that elements found on the periodic table, specifically group 18, are less or unreactive in the sense that they have fully filled valence electron configuration. Yes, and as a result, they are more stable. Now, the reason why elements become more reactive or undergoes bonding processes is in order to attain stability. Are we together? Yes. So I want you to take note of that. Now, it serves as a foundation for the production and development of materials, medicine, and technologies. So the periodic table, or the application and the importance of the periodic table. So this is another importance of the periodic table. And then the periodic table helps in conducting research, promoting environmental stability, and exploring new frontiers. Periodic table, that is trends and variations of the periodic table. Now, so we have electronegativity, electron affinity, ionization energy, atomic radius, effective nuclear charge, all these enthalpy of atomization, all these are examples of the periodic trends and variation. But for time factor, we will talk about this few, and as we proceed, we'll hit all those stuff. So we talk about electronegativity. We are just talking about the ability of an atom to attract or to pull the shared electron towards itself in equivalent bond. And in most cases, it leads to distortion of the structure of the other atom with less electronegativity. So electronegativity indicates an element's ability to attract electrons in a chemical bond, leading to variations in reactivity and bonding behavior. All right. The next is the atomic radius. Refers to the size of an atom, which influence its interactions with other atoms. So that is the distance from the center of an atom to the center of the other that are bonded together. Yes, and or you can say from the nucleus, which is the center, to the valence shell. So let's take note of that. And it determines the element physical properties. We have ionization energy, the energy required to remove electrons from an atom, providing insight into the element stability and electron configuration. One of the things is that elements such as metals normally or they easily donate electrons in order to attain stability, to be more stable. Yes, and one of the things is that anytime that they donate this electron, they become positively charged in a sense that the number of protons exceeds that of the electrons. We've learned already, you can check our previous video lesson, we learned that um, anytime an atom loses an electron, it becomes a positively charged known as a cation, and then when it accepts or gains an electron, it becomes a negatively charged known as an anion. Apart from that, also we learned that anytime the electron is being donated, the electrons are negatively charged and the protons are positively charged. So when you remove an electron, which is a negatively charged, then the number of the positive particles, which is the proton, exceeds that of the negative particles, which is the electrons, and in that way, that atom or that species will have a positively charged. Okay, and then we said that when it gains, then it means that it gains an electron, then it means that the number of electrons or negative charges now exceeds that of the positive charges, and in that sense it becomes a negative charge particle or species, and it is termed as an anion. So let's take note of that. So ionization energy is that minimal amount of energy required to remove an electron from an atom, okay, providing insight into the element stability and electron configuration. So when the electron is being removed, that atom become an isolated gaseous charged particle. Are we together? It becomes a cation charged particle. In other words, it will be bearing a positively charged. Let's take note of it. So this will be the end of this lesson. I remain your facilitator, Dozaman. Don't forget to like. Love you.